Hello, everyone. Welcome to the June edition of the Azure Cosmos DB Global User Group. I'm your host this month, Mark Brown, and I'm joined this month with Florian, Eiden, and Ajeta. Okay. A little technical issue here. We've lost her video, so hopefully Ajeta will join us here shortly. And this month we're going to talk about Azure Stream Analytics. Oh, there she is. Hello.
Hello.
Good to see you. Say hi, everyone.
Hello.
Good to see you. So, Florian and Ajeta, why don't you kind of kick us off and talk about what we're going to explore this month with you all.
Sure. Thanks, Mark. So it's really exciting to be here. Really happy to be talking about Azure Stream Analytics and how nicely it plays with Cosmos DB. So I'm Florian Eiden. I'm a product manager at Microsoft in the Azure Stream Analytics team. I've been in that team for a year, and my area of expertise, of responsibilities around the SQL language that we use. And with me is Ajeta.
Hello, everyone. My name is Ajeta Singhal. I work as product manager on Azure Stream Analytics with Florian as well, and we are doing some great things that we want to show you today.
Awesome. So we wanted to get started by kind of talking about Stream Analytics, what it is, and then telling the story into how it plays nicely with Cosmos DB. So the kind of the domain we're going to be looking at right now is near real-time analytics. So really what qualifies as near real-time. And what we're thinking about, what we're focused on here is low latencies. And by latency, we mean the time to insights. How many seconds, milliseconds happen between when something occurs in real life, in business, on a process, and when you can access that information, transform it, ingest it, and build some kind of analytics on top of it. So real time is where really you do edge deployments, where you do local analytics. There are strict guarantees. It's a synchronous process. Here we are in near real time. So your processing can happen in edge or cloud. Usually we're around milliseconds and minutes. And then usually you know already about batch processing, where you're scheduled, could be down to the minute, but usually it's the hour, week, or month, day, week, or month. And yeah, so here we're really about near real-time analytics, lowering that latency between milliseconds and minutes. Why? Why would you want to do that? There's multiple answers to that. The first one is, for some use cases, the signals, the data points that you will be reading from have a very short shelf life. And by that, we mean if you get some telemetry in your factory about a big machine on your production line, and it's starting to burn, you need, there's a fire starting up, temperature is rising, you need to know right now. You cannot wait an hour or a day or a week to react to that. So very short shelf life for that signal. The time to insight is also critical. So if you need to be alerted, if you need a notification, if you need to know and detect about a fraud happening, you cannot wait a week to know about a fraud. You need to be able to block the transaction, the commercial transaction in your e-commerce store right now. So that's also the second point of why near real-time analytics is really important. Then there's just the fact that most business processes now are happening in real time. So why introduce a delay? If you have an entire workflow where applications, an automated workflow where each piece is a service, a piece of software talking to one another, why introduce delay? Why put batch and time, like waiting periods in between each of those steps? You can just go straight through with real time and near real time. One important aspect of near real time analytics are the data streams. So what we call data streams are continuous flow of events. You can think of it as data in motion. So coming from Cosmos DB, you know about data at rest. You know Cosmos DB is a database. You can store data in there. Here we're going to be dealing with data streams. So data that is in motion, in queues, flowing from one system to the other. So that sequences of data ever growing and often with a limited retention due to the sheer volume of that data and the fact that also it's perishable. Usually, you can only access the last 1 to 7, 10 days of data. So you need to be able to process them, ingest them, and potentially put them in a database like CosmosDB, and that's what we're going to be talking about today. And events are facts, so something happened, and usually they're broadcasted. If you think about event-driven architectures, the event log, event bus approach of systems communicating asynchronously via a bus, that's what we're talking about. As soon as you go into an intent, like a command and a job, that's another domain. And that's just a quick example. Here we have like a production line, manufacturing a factory with two big, I don't even know what those are, but they are doing something important. And here we can see telemetry being emitted, and we will need to process. So each of those has an ID, a timestamp of when that measure was taken. And here we have a pressure in PSI and a temperature in degrees Celsius. And that's just data flowing in motion, being transported in a queue like Event Hub. And we're going to be talking about Event Hub. In terms of the application, what is stream processing? So stream processing is extracting value, insights from those data streams. And we kind of see three top-level patterns here. One is how to extract value from a stream to an application. So usually when you think about those use cases, like around CosmosDB, that's one that's going to be a very good one. When you need to apply some rules engine, so if my temperature is above 75 degrees, then let me know. You can generate derived events if you need to aggregate data on the fly. Let's say calculate the average of temperature across my factory or across my fleet of devices. That's also a good use case for stream processing. The second one is stream to data store. So usually it's a streaming ETL to a database, data lake, whatever. That's also like stream processing is very good for that. And the third one is stream to the human eye. So if you need to generate that notification, that ping that you're going to send to your end users, generate a real-time report, real-time dashboards, that's also a very good application of stream processing. So that was kind of the domain. I just wanted to have a high-level introduction, high-level overview of the field of the possible, what we can do with stream processing. And now we can talk about Azure Stream Analytics. Azure Stream Analytics is the Azure service that's native in Platform as a Service, and we are live since 2014. So it's not a new kid on the block. That's a service that's been in prod and running in GA for a long time. So we're based on a library, high performance in memory analytics library from Microsoft Research called Trill. And it's now open source, so you can have a look at it if you want. And we're Platform as a Service, and we're managed, obviously. So you just need to think about your use case, and we can take care of that. So just a little illustration of how usually it goes, but we're going to see how we can make that better. So I want to know when an equipment has its average temperature per minute raising above 90 degrees. You remember that JSON payload that we were looking at? Well, that's a very simple SQL query. And then I will get an alert, and I can react on top of that. That's something we can do. And that's the kind of canonical architecture. So a job is part of an overall architecture that starts with devices or clickstream, logs, customer data, financial transactions, or business applications, generating those stream of data into an event broker. And by event broker, so that's just basically a queue. So most often we're using Event Hub there. That's going to be ingesting all of that data. And then we can use Stream Analytics on top of that to query, generate insights, reading from that event broker. And of course, you need a sink, a destination, so an input, some kind of query, how would you implement your business logic, and then an output, where do we deliver? So if you need to do some messages or derived event and notification, you can go back to an event broker, but of course you can target CosmosDB. A dynamic application, so there's need to be reaction somewhere, your UI need to be updated, but the fact that something happened, again, you can use functions, logic apps, you can use CosmosDB. For data stores, well, there's blob storage, of course, but here we're kind of in a document. Quite often, those event broker, the data that's coming on is document-oriented. So that's going to be JSON, that's going to be Avro serialization format. Well, going to CosmosDB makes a lot of sense there. storage archival, obviously, and real-time dashboarding. You can target Power BI directly, but why not use Cosmos DB? So we can see a pattern here about how Cosmos DB plays very nicely with Stream Analytics as part of the output. And again, those applications from Stream to apps, Stream to data stores, and Stream to the human eye. I just wanted to dig a little bit on the Stream to data store. So there's a pattern around like streaming ETL. How can you extract that data that is using a specific schema, but doesn't match the schema that you need to have in your database? Well, that's ETL, extract, transform, and load. That's what the functionality that Stream Analytics will bring to the table. How will you be able to evolve, change your schema? You can do that on the fly in Stream Analytics before loading that data into Cosmos DB or your database. And that's the pattern that we're going to be talking about today, the streaming ETL, where you take that data coming in real time, apply some kind of transformation, data cleaning, changing the format, the data types, and then you insert that into your Cosmos DB. Just drilling a little bit further down, thinking about a job in Azure Stream Analytics. So Stream Analytics, when you develop a Stream Analytics project, you create jobs. And a job consists of a SQL query, but we'll see about that. But at least obviously one input, we need to read from something. So even Hub, here that's my transactions. I think the demo we have for you today are around a leaderboard. So scores coming from like we have a player tag, a timestamp, and the score, how much like a player scored in a game. So at least one input, at least one output, of course, and actually some functions, but I don't want to talk about that right now. And then you're going to be able to write your SQL query for that. But like, do you really want to write SQL query? Like, we have a very featureful SQL language available, and I know because that's my area of ownership as a product manager on Stream Analytics. Like, I really love what we have. It's a subset of T-SQL, so the SQL that's part of SQL Server, and we have lots of language elements and functions. We offer a lot, but sometimes just don't want to write SQL. And that's where I'm going to hand off the mic to Ajeta to talk to us about the brand new no-code experience that we offer.
Hello, everyone, and thank you, Florian, for a great introduction. So today I'm going to talk about the no-code drag and drop experience. And it basically, the slide that you just looked at, it talks about how you can create your streaming pipeline without writing any code in just few clicks and few minutes. And the benefits of that is that you can be more productive in the sense that it doesn't take so much time to stitch various Azure services to put together the streaming pipeline. It's just few clicks in which you can create the streaming pipeline, and you can instantly validate the logic of your query. So let's dive into the demo. So I'll start from Event Hub instance, as Florian said that you need input for your query. So that's where your real-time data would come in. Starting from Event Hub instance, you would go on to process data. And in process data, you see that we have some templates that you could start with. Some example of template is that you can filter ingest to Synapse SQL, or you can capture data to ADLS Gen 2, or just quickly materialize data in Cosmos DB. And the fourth demo is filter and ingest to ADLS Gen 2. So clicking on one of these templates would actually get started with a canvas where you can drag and drop and quickly create your queries. We also have a blank canvas if you want to start with. It's for little advanced users in the sense that if and once you have experienced creating queries from these templates, then you can start with blank canvas as well. So for today's conversation, since we're talking about Cosmos DB, I'll pick the Cosmos DB template and say start, and I'll give it a name. Let's say I'll give a demo job for today's meetup, and I'll create a job. So as Florian talked about Azure Stream Analytics jobs, you have to create jobs in order to create pipelines, and that's our concept. I will zoom down a little bit and hopefully you can see the whole canvas. Is that better? Can you all see?
Yep, it's good. If you need to zoom in potentially on a specific piece, but like for the overview, it's good.
Okay, perfect. Thank you, Florian. So I'll connect to, so we started from this Event Hub instance, and we have all the settings already, but I'll just check what is my serialization format, as we have 3 types of serialization formats supported. But since my data is coming in JSON format, and I'll select any consumer group, it's default. If you want, you can change it, but everything is already pre-configured. I click on connect, and it'll start showing me the data that's coming in my Event Hub. So let's wait a couple of seconds. So the connection test was successful, and let's wait for data to load. Okay, so I have data coming in, and it's a cryptocurrency data where I have some market price and some symbols of the cryptocurrency, and some timestamp as well. Let me try doing a group by. So the power of this template is that you can quickly see the data that's real-time data that's coming in, and we have a bunch of operations that you can try here, like you're filtering, you can manage fields. If you want, you can do some aggregations, you can do joins, group by, union. And for this template, we have group by that we have configured, but if you want, you can bring in more of these. So let me just start with what we have right now. So here, let's look at the data. So we have all these fields that are coming in, and if you want, you can do other operations. Like you can remove a field if you don't want in your schema. You can rename, or you can also change data type. So here you can see that, for each field, what are the different data types that are supported. So let's say, for example, for ID, it's a string that's coming in. So you can actually check each data type as well. Now going into group by, I want to specify some more aggregations. So let's say I specify on what symbol is coming in. So I will go into, let's say, average, and go into, one second. Yeah, so I have some market data that's coming in as array. So I'll select the price and save it. And it's saying it's going to show an average of the price in US dollars. If I want, I can specify more aggregations. So let's say I want to specify a symbol, and I want to just aggregate over a tumbling window of 5 seconds. So that's a group by that I specify. So basically, you do not have to write any code. You can just specify in the UX, very simple. And let's define a Cosmos DB where I want to send it. So let's say I pick up. So this is the subscription that I select and database. And if you want, you can select any container. And I just say connect. And you're done. So it's going to show me the preview. And if you want to see what's going in group by, you can see as well. So when I said you can instantly validate the logic, that's what it's doing. The data that's coming in, you specified a group by function very quickly without writing any code. You instantly see what's the result of your group by. And also you connect to your Cosmos DB super fast. You do not have to provision any different service. You just drag and drop and specify here with simple UX, and you save your query. So when I say save your query, you're actually saving the Azure Stream Analytics job, and then you can start it. But before starting, if you want, you can bring in more fields. Like let's say if I want to do manage fields, and I want to connect it between the Event Hub and the group by, what I do is I connect like this. And maybe I want to specify some fields that I want to add. Let's say in field, I want to specify the metrics. And in metrics, actually, since it's an array, nested function, so I'll just do price, save. And okay, I did not specify the right one. But basically, you can do filtering as well. Let me try showing you filtering also. So you just do a drag and drop and connect between different nodes. And then you can specify, let's say if you want to specify any filtering logic, you can do that. So maybe I want to do symbol equals whatever symbol, and then you group by on that. So basically, yeah, it's very easy to define any of these operations. So let me remove this and go with my original query, where I just want to group by on a very simple event hub data, and this is my query. If I want to start, I need to save it, and I start this Stream Analytics job. It's very simple. You've already given it a name, which is demo job meetup. You specify start time. If you do not want to specify custom, it just starts from right away. There are default streaming units, which is streaming units is basically for Azure Stream Analytics. And you define any of the error handling policies, which is retry or drop. Default is retry, and you start it. When I start it, what happens is it starts writing this group by logic into the group by data into the Cosmos DB. It takes a few minutes to start the job, but the idea behind this demo is it's super simple to start it from here. You do not have to go outside of Event Hub instance to create another Stream Analytics job or create another Cosmos DB, and you can start very easily. So before the demo started, I already have a job that's running with exact same logic and exact same Cosmos DB. So as you see here, Event Hub data coming in, exact logic going into the same Cosmos DB as I had configured. And when I started this job, it's been running for quite some time. And it tells you what the streaming units it's running with. It's been writing data since this time. It's the latest that I received the data on. And if you want, you can open the job monitoring. I'll show you in a bit. And if you want, you can stop or delete a job from here. Now, let me show you. I actually go into my Cosmos DB, which was this container, and it's already writing all the data that I had configured in the job. Now, if I want to see how my job is doing, I actually open the job using this, and it shows me how my job is doing, which means it'll go to this metrics view, where I can see that how the CPU utilization is, how my streaming units utilization is, how many input events are coming in, what's the output, any delay that's going on, or any backlogged events that's happening, or any sort of error. So it's super easy to see and troubleshoot by looking at these metrics and monitor your job. Now, going back to this drag and drop experience, if I want, I can go and stop this job and add more operators. As I said, you go in here, you can stop this job, and you can add more operators and then restart the job again. If you want, you can create more jobs using these templates, or we also have a blank canvas. So let me show you what a blank canvas looks like as well. Let me give it a name. All right, so this is my Stream Analytics job, and you have the Event Hub instance. You just need to connect it. Let's say, let me try connecting again to show you another very simple scenario. And then let me do a filtering on that. So here, as you can see, the template is not there, but you are creating from scratch. So it's super simple as well. You just drag and drop and start creating. So your data is coming in, and let's say I want to simply filter on a symbol, which was, what was the filter? BTC probably. And I want to send it to my, for example, ADLS Gen 2, and I simply connect and select any of my ADLS Gen 2 as well. Here, let me quickly connect one. And it'll start showing you what is the data that's going to go into ADLS Gen 2. So immediately you can see, instantly validate the logic of what's going on in your operator, what's going in output, what's going in input. You can save your job, you can start, and instantly in few minutes, it will start going, showing the data going into in this ADLS Gen 2. Okay, thank you. That's it for my demo.
Awesome, thank you very much. Mark, if you want to switch back to Slides. Yeah, thank you. So thank you, Ajeta. That was awesome. I love that, like, everything refresh in real time. Like you can see live what's going on in the pipeline, and when you like change a previous step, how immediately we can detect in the following layers that something went wrong, that you need to fix it. I just love that. It's awesome. But I'm like, yeah, I like it. But I like SQL. So of course I'm going to be talking about SQL. And taking a step back, looking at all the experiences we have right now. I am a developer. I want to use Azure Stream Analytics. We have 3 development environments right now available. One is, so the one that we just, Ajeta just showed is the no-code editor, which is currently preview. And that's fully visual designer, as just witnessed. And it's accessible from the Event Hub blade. So you go in your Event Hub, that's your event broker, where all of your data is being streamed. And from there, you can just have that experience. The approach that we're taking here is that this is a little bit like an infrastructure piece. It's not really code as in their source control, their CI/CD, their unit testing. No, this is a bit of infrastructure that we allow you to use to generate a pipeline that's natively going from Event Hub to Cosmos DB. But sometimes you need to do more complex business logic, and you need that pipeline to not be considered as infrastructure, but as code. So you need to be able to test it, to put it in source control, and to have a release pipeline that's going to allow you to do CI/CD. That's usually where we recommend Visual Studio Code. And that's what I want to show you right now. So I'm going to go into VS Code. Okay, and I created a Stream Analytics project. So the way it works is we have an extension that's called Azure Stream Analytics extension. So it's pretty easy to find. And here it is. And of course, it's already installed. But you just install that extension. And the next time you press F1 in Visual Studio Code, you will get the create a new Stream Analytics project. So ASA, Azure Stream Analytics, create a new project. And what it gives you is it creates a folder with some scaffolding, some files already there. One subfolder to define your inputs, one to define your outputs, and then Canvas to actually write some SQL for your Stream Analytics job to perform the business logic you want. So here I've already configured an input. So to create a new one, you can just do add a live input, and we have the whole experience via that wizard, which gives you a JSON file that's already pre-configured. Here I'm reading from Event Hub using your connection string. Again, serialization is JSON, etc. I can change, I can play with that, but here that's not the point. Then I can define similarly an output. Here that's going to be Cosmos DB. So similarly, I can add another output, find Cosmos DB, and select using the wizard, and it will generate that JSON configuration file in the end, where I can target a specific database with a container name and a document ID. That's what I did. Now that it's set up, what I can do is go into the query and do a select star from live scores. Live score is DL, yes, the name of my input. And I can run locally. So now this is running 100, I don't even need an Azure subscription for that, specifically running that. And I can use a live input. So I'm going to connect to that Event Hub, extract data from it, and apply that query logic on top of it. So that's what I'm doing right now. And I'm sorry, I'm running at 200% zoom, so it's a little bit, the UI look a little bit wonky, but that's because I'm zoomed up. Maybe I can zoom out a little bit. Okay. So the job is being started. I have some log, of course. It gives me, so here I'm reading from Event Hub, 8 partitions. I have a query step with 8 partitions, and I have a local output, which is not partitioned. So I have a job diagram to understand and troubleshoot my query and understand and each of those nodes has metrics. So I can dig a little bit deeper and troubleshoot my performance issue if I have some. I can use that experience to do that. Now, just to look at the results. So in my output step, what data do I have? So I did a select star because here right now I'm not exactly sure what data I have in my event hub in input. Here I said I have a player tag, a game and time, and a score. So that's my payload. The rest are like system columns that are added by event hub. But that's a very simple use case of a leaderboard, looking at results from players playing my game in real time. And one thing I want to do here is doing an aggregation. So I want to know, kind of build a leaderboard, and I want to have the count of game, calculate a ratio. So how many games did you play, and what's the score, the sum of score, and then divide that sum of score per the count of game I played to kind of get my winning metric that gives me how good I am at that game. So let's just do that. So here I'm going to need the player tag, obviously. Then I need to count the number of games. Then I need to sum my score over the period. And then I want to calculate my ratio. So that's going to be sum of score divided by count star as ratio. Okay, that's good. But I'm operating on a stream. That data, as we mentioned, is evolving in real time. So if I want to do a group by, so first, obviously, I'm going to put the player tag. I'm also going to need that window that Ajeta mentioned, the tumbling window. Here, I'm going to use a hopping window. So what a hopping window does is, and we have, of course, IntelliSense can explain you, we have links to the documentation with schema, diagrams, etc. This is very specific to stream processing, not specific to stream analytics. Every stream processor has that aspect. How much time do you want to look back to calculate that count and that sum? It cannot be since the beginning of time. Like we are looking at data in motion. We need to say for the last day, for the last hour, for the last minutes. So here what I'm going to do is, for that, I'm going to look at the last 60 minutes. So when you do that count, when you do that score, look back the last 60 minutes, but refresh that every 1 minute. So every 1 minute, look back to the last 60 minutes and calculate those aggregation. And I already know the data a little bit, so I'm going to add a filter, but that's post group by, so it's going to be a having clause, and I want that over 60. So now I have a query that's a little bit more complicated, a little bit more interesting. That there's one thing that's missing. Here I'm going to have a list of player tag with the number of game played, the score, and the ratio. What I'm missing is when. When did that happen? And we have a magic keyword here, a magic function in stream analytics. That's system.timestamp. I don't know if you realize that Ajeta pretty much did the same scenario, but that one was put for you by default inside of the query results, outside of the aggregation. So that's the kind of nice thing you get with the no-code experience. You don't need to think about those special functions. That window end time will be there already for you. Here, since we are writing this query, we need to think about it. So yeah, it looks good. So let's stop the previous version of that query that was running and start a new one. Okay, so now I'm going to be connecting again to my event hub, load some data, apply the query logic, and let's see what it gives us. Not connected yet. Oh, that's still loading. So I'm on an old Surface Pro, so some of those take more time than they should. Okay, what's going on now? Of course, something wrong had to happen during my demo. We joked with Ajeta, knowing, guessing which one of here it is. Which one of our demos would go wrong? Well, it looked like it was going to be mine. So here we are. Now we have that same data. Now we see at minute 34. So right now it's UTC time, but I could move that. At minute 34, the player 443 for the last hour played 64 games with a total score of 295 and a ratio of 4.6. So that's good. Maybe it's a lot of game. Maybe we should be worried about that, but it's randomly generated data, so obviously it's going to make no sense. I like that. That's a good query. So now what I can do is create a job out of it. So I'm going to output that into my Cosmos DB, just really simply doing that. You can stop the local execution. And what I'm going to do is submit that job, so publish that job on Azure. So now I'm going to need a subscription. I'm going to create a new job. I'm going to put it in that resource group, the standard job, and I'm in Canada, so I'm using the Canada data center. And now I can just publish that to Azure. Here it goes. So now I can switch to the portal to see my job being deployed. So I could stay here. I'm going to be loading all the telemetry. I have the job status, etc., the activity logs. So the job's created, and I can actually start it from here. So again, I'm going to start it from now. So those are the resources, the streaming units we mentioned. That's how much compute, how much scale do you need. Here, this is a very, a minimal job. There's not a lot of, I think it's a kilobyte per second. So I'm going to use just one streaming unit, the minimum, and just say, okay. So now the job's going to be starting. I don't need to look at it. And I can switch to the Azure portal. Where's my Azure portal? Here it is. So I'm in the Azure portal, and there's multiple things that I want to look at. The first thing is here for the demonstration, I'm using actually a function. And why is it not loading? Okay, here we are. Let me check that the other one are still there. This one's there, this one's there, and this one's there. Okay. Yes, so I'm using actually an Azure function to generate the traffic. And with function, that's actually a PowerShell function that's emitting records to Eiden Hub, just for fun, for like the sake of that demonstration. Doing like calls and generating like random data. And here we are. You can see there's an output, and we are just sending player, timestamp, and a score to Eiden Hub. So to that Eiden Hub that I created previously. Here I can see how many requests, the messages, and the throughput. So that's nice. So remember, so that's where Ajeta showed us from here. I can actually process data. So that experience, it starts here in the Eiden Hub portal in the process data blade. That's the demo that Ajeta just did. But here I actually deployed a new job. I created and deployed a new job. So I'm going to go look at my jobs, filter them by my name. That's how I find them. And it should be scores 2. That's the one. So now I'm seeing the code, the job deployed in Azure, running live 24/7. So that's what I'm looking at right now. So I think it's just like got started. It's still running, and we should see all the metrics. So resource utilization. Was I good? Like picking one streaming unit? Do I need more? So I will know about that. How many events did I read? Watermark delay is how much delay between my ingestion and my output, and if I have any kind of issues. So let's go back to the one that's I created before and was already running. So we have a little bit of history in terms of monitoring. So it's exact same job. So if I look at the query, and that's the third developer experience, and actually can configure, test the query, edit the query if the job's not running. When the job's not running, I cannot do that. Here directly in the portal. That's the third user experience that we offer with Stream Analytics. But here I'm already picked VS Code to work on that. I just want to look at the metrics, and I want to look at the last 1 hour. And I can see my resource utilization. I'm at 5%, so I'm all good in terms of CPU. Memory is around 14%. This one I think is running at 3 SU, so I could scale it down. How much events I processed in input versus output. I'm doing an aggregation, so it's good that I'm actually outputting less than I'm reading. My watermark daily is good. Sometimes I have spike at 1. I just realized that I was maxing my RU on the Cosmos DB output. So it was kind of a like backlog pressure. And sometimes I had like 429 errors, but I just upped it, so I should be good. And now I can look at my Cosmos DB. So here my container is the hourly scores. And I can go and look at my items and see that I have my window end. So when was this score generated, the player tag, the number of gameplay, total score, and the ratio. So of course, obviously here I can order by see the ratio desk. And now if I take the top 10 of that, well, now I have my top 10 players for the last over the last hour. I can do that. We have a customer doing that for 24 hours period. We have customer doing a lot of variation around that, but that's really simply looking at the telemetry you're emitting from your game into Eiden Hub, building that query into Cosmos DB, and I can build a web app on top of that. That's going to give me the top 10 players over the last hour. Very simply building that story end to end. So that's what we offer, like Streamatics plus Cosmos DB, and you can pick how you want to build that. Getting back to the slides. Here we are. I'm going to go full screen. You can do that in the portal. You can do that via VS Code, but still writing SQL. So both portal and VS Code with the extension. This one, you don't need to install anything. This one, VS Code, you get CI/CD, unit testing, custom code, etc. And the new no-code experience that we just released, where you don't even need to think about SQL. You're just picking your Eiden Hub, picking your Cosmos DB, adding no-code, just picking the options you want, the transformation you want, and you're just done. So all the different ways to build that query. And when you think about specifically that end-to-end pipeline, you may have noticed that we support a lot of different outputs. We don't not only support Cosmos DB, we support like a storage account. You can use SQL, Azure SQL, PostgreSQL, Synapse SQL, pools. We support a lot of destinations. Why do we often recommend Cosmos DB as the database of choice for Stream Analytics? Two main arguments here. The first one is stream processing and data streams, I would say 99% of the time, are documents. They are JSON or Avro payloads that will need to be processed. And you will have arrays, you will have records. And naturally, going from a document stream to a document DB, it's just really easy and straightforward. You're going from schema on read to schema on read, just works. If you go from a document stream to a relational table, so a table in Azure SQL, for example, you will need to be very cautious about data types and the schema, all the schema management and schema evolution, like adding a field, removing a field, changing the type of a field that is missing may break your pipeline, which is not good. When you go to document stream to document DB, you have something that's very resilient and can go through schema changes, go through transient errors in the data type and just be resilient about it. So this works really, really great. So that's the first point. The second point is the scaling story. So Azure Stream Analytics is a big data system in the sense that it's a distributed system. When you pick a streaming unit, as long as you're under 6 SUs, you're running on a single node behind the cover. So sorry, it's going to be a little bit technical here. But when you go over 12 streaming units, you start using multiple nodes. So we, under the covers, hidden from you, outside of the telemetry, obviously, we start like provisioning clusters that have multiple nodes. And we need to distribute work on those nodes for you to benefit from adding more resources, more compute to gain more performance. There's two ways for us to do that. One is we parallelize the jobs. So if you have multiple partitions in input, and Event Hub is also partitioned, and you have multiple partitions in output, and as I'm sure you know, Cosmos DB, partitioning is a very important aspect of it. If all of those partitions are aligned, then we can put one node in front of an input partition that's going to write to an output partition. So we will get, in that case, where we are highly partitioned and we can be highly efficient and scale up at the maximum scale that we can offer, which is a lot. So Cosmos DB natively lives here. Cosmos DB is partitioned. Event Hub is partitioned. Like, the partitioning and scaling up story just works great on that end-to-end scenario. If you're targeting SQL, for example, and again, I'm not saying it's not a good database, but specifically for that use case, there is no notion of partitioning out of the box with Azure SQL. You need to think about it yourself, and you need to create partitions, and then the configuration is going to be a little bit more complicated because you need to inform us of the partitioning scheme you have. Cosmos DB, out of the box, everything works great, and you can scale up to any kind of performance need. So 2 points that makes Cosmos DB and Stream Analytics really work great together. So that's everything we had for you, going from so the value of Stream Analytics, the domain that we're working on, how we're reading from Event Broker, Event Hub, how we offer 3 developer experiences, 1 in the portal using SQL, 1 in VS Code using SQL, and a brand new one just released, no code, directly from Event Hub, just drag and drop to Cosmos DB. Why Stream Analytics plus Cosmos DB is an awesome experience. Schema management, awesome. Partitioning, awesome. I hope that it convinced you to, if you didn't know about Stream Analytics, give it a try. So we put some links here to getting you started. We have quick start, really easy to go through. And a little bit more, learn more is about the theory of stream processing and why do you need those tumbling windows. Those are good documentation to get started on that.
Yeah, this is great. Thanks, Florian. It's a little hard. I should have asked for you. People can't click on those links.
No, I need to share that. I'll put it on the meetup.
What's that?
Can I put the deck on the meetup?
You can. I think. Or you know what, the easiest thing you could do is to put a comment on our meetup page for this meetup, and if you've got your deck available, like on GitHub or OneDrive or wherever you want to share it, or you can just put the links in a comment.
I'll put the links as well. I'll do that. Yeah,
that's fine. That's fine. And then folks, you can go ahead.
We're really easy to find. Like, if you search for Azure Stream Analytics, Azure documentation, I'm pretty sure you can find us. But yeah, I'll put all the links.
We can track you down. Yeah, we'll find
you.
This is awesome. I love the work you guys are doing. The no code. It's so that's like the new hotness these days, isn't it? Everybody going with a no code environment there or experience. Yeah. But you've got kind of the full spectrum there, from just your straight up portal experience there, which pretty much everybody has, and then a good developer experience there with testing and CI/CD integration. I mean, that's great stuff that you've got there, all wrapped up. So people can come with the level of depth they need and start using you guys. Yeah, it's great stuff. I love the work you guys do. A lot of people using Stream Analytics with Cosmos for all those reasons you mentioned. It just works well together.
Yeah, the story is good. Like, Azure Stream Analytics plus Cosmos DB just works great.
Yep. I didn't get any questions from anyone. I think you guys just kind of hit it out of the park there with your presentation and your demos. So yeah, thank you so much, you all, for joining, and thank you all for joining and watching us today. And thanks for coming and being a part of our virtual user group for Azure Cosmos DB. We'll be back again next month. We don't have it up yet scheduled on the meetup page. At least I don't think we do. Check. Nope, not there yet. But we'll get a new one up here soon. And then we hope to see you again here next month for the Azure Cosmos DB virtual user group. So Florian, Ajeta, thank you so much for being with us this month. It was really, really great to have you.
Thanks for having us.
Thank you so much. Thanks for having us.
Thank you so much. And everyone, we'll see you next month. Thank you.
Thank you. Bye.
Bye.